Activity 11.12 is area on Geoboards. So again, these are polygons. We said if it's a shape we have an area formula for, we're going to use the formula. If it's another shape, we're going to try to cut it into shapes that we have a formula for, or the third technique is going to be creating a square rectangle around the shape and subtracting extra. So A is that same parallelogram we found the perimeter of. For area, we do base times height, right? So this is going to be base times height because it's a parallelogram. So the base here is 3. The height is on the inside perpendicular to the base, and the height is also. So 3 times 3 is 9, and now we will have units squared for area. The second one, let's see if we can share the virtual geoboards again. Okay, so this is shape B, and we have this odd shape. We don't have a formula for this. And if you remember, you can only measure units on the vertical or on the horizontal inside of your on your geoboard. So let me get another rubber band here. And I'm going to stretch it across. And see what I did here? I have a triangle on the left, triangle on the right. The white rubber band will be my base. The smaller triangle has a height of 1. The larger triangle has a height of 3. And just like that, I can use the area formula for a triangle, and I can go ahead and add those two areas of the two triangles together. Okay, so for B on my notes, I have colored the two triangles. So the orange triangle, the larger triangle, I set that line that we put the white rubber band on is going to be our base. So that's 1, 2, 3, 4. So that's 3 units. That makes the height in the orange triangle 3 and the height in the green triangle 1. It might help you to rotate the piece of paper to really see that height's perpendicular to the base, rotate it the other way. You see that the 1 is also perpendicular to the base. So I'm going to have 1/2 base times height. 1/2 times 4 times 3. Half of 4 is 2. 2 times 3 is 6 units squared. The green triangle is also 1/2 base times height. 1/2 times 4 times 1. Half of 4 is 2. 2 times 1 is 2, and this is squared. So the area is now going to be 6 plus 2 plus 8 units squared. In C, different ways to look at this. This is a pentagon. You can go ahead and cut it with a triangle and a trapezoid maybe, or whatever else you see. Doesn't matter how you cut it, your final answer will be the same. D, so you cannot connect it, the two triangles here, or create it from a dot to a dot, right? So I can see that I could create one here, and I don't get a triangle. I cannot connect this dot to that dot because the rubber band is not touching this dot. So one technique that I will show you for D is the one I talked about, where you take either a square or a rectangle. This happens to be a square, and you will subtract the area. So the area of the square, 1, 2, 3, 4, 1, 2, 3, 4. So I get a 4 by 4 is 16. We're going to subtract. I'm going to subtract 1/2 becomes 2. I'm going to subtract this from the triangle minus 1/2 times 2. I'm counting on the sides here, right? It's able to be 2. That's what I'm getting those numbers from. let's do more down here. Okay. Minus 1/2. What do I have? I have 16. Minus half here is 1. 1 times 2 is 2. Minus half is 3 times 2. 6 is 3. Minus half 4 is 2 times 1 is 2. So I will use a 7. So I will get 9 units squared. This method, by the way, works for all of them. You don't have to go on a 4x4. You can just enclose the shape. B looks like a rectangle, except for none of the sides are either vertical or horizontal. So you either have to divide it into shapes that we know how to find the area of, or to the outside and subtract. F and I have something in common. So for F, similar to B, I can see a triangle here, but look at this triangle, which is the same as I, and that is, I have this space is 1. Now the height has to be perpendicular to the base, so it's possible you have to extend your base and then measure all the way down to get your height perpendicular to your base, but the height's actually on the outside of the triangle, which is okay. Your height here is 1, 2, 3, 4. It's still going to be 1/2 times base times height, and you end up with 2 units squared. H has got an interesting shape. Again, you can cut it on the inside or the outside. It is possible to get fraction answer, so that are not going to be all whole numbers. And G, I would be the outside for that one. It's up to you. So this is one where I said you don't have to go all the way. You can go here. And so you would have 4 areas to subtract. 1, 2, 3 triangles and 1 rectangle. H, again, you can do the outside or the inside with that one. I think I did the outside before. All your answers are going to be in units squared. Let's go to the next page. We're going to put area and perimeter together. So we've already done perimeter on Geoboards. Now we're going to find a shape that has an area and a perimeter that's given to it. So we create the shape. If I want the area to be 5 units squared, so each little square is 1, right? So I need 5 of those, and I need the perimeter to be 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5. That one would work. That's one example. Here's one with decimals. The area is 5.5 units, and the perimeter is 3 times the square root of 2 plus 6. So 3 times square root of 2 can be square root of 2 plus square root of 2 plus square root of 2 plus 6. And that 6 can be divided up just like the 10 was, right? The 10, here's a 3, a 1, some sides 2. You can divide up that 6 however you want to. And if you remember when we started talking about geoboards, we said that if you have this 4 dots, let's put the right triangle. There's a 1 by 1. We had 1 squared plus 1 squared equals, and with a question mark squared. 1 plus 1 plus question 2, question mark squared, square root of 2, and question. So that means that a square root of 2 is just a diagonal between 2 pegs. So if you connect, for example, 3 of these, then you would have 3 square root of 2. I hope that makes sense. Okay, so play around with that one. And then the last one is 2 square root of 2. So again, that could be square root of 2 plus square root of 2. Square root of 17. So let's think about up here. So we end up with square root of 17. I'm going to work this backwards, is the question mark. So 17 is question mark squared. So let's think about 17 to be split into two numbers that are perfect squares. And I think of 16 plus 1. So this would be 4 squared plus 1 squared. So that means if I just take a part of the geoboard, and I have one side that is 4, and one side that is 1. The hypotenuse of that triangle is the square root of 7. And this is a triangle. So hopefully that will help you because you're going to need a 4 by 1 where the hypotenuse is square root of 17. So the hypotenuse is going to be part of your shape. The area has to be 7 units squared. So try the last two.